the sine function is not invertible because it's not one-to-one until we restrict the sine function on a smaller interval, such as from negative half of pi to half of pi. Then we can find inverse sine function. For the same reason, we need to restrict the cosine function to an interval so that we can make it one-to-one first, right? Then we find its inverse. So let's think cosine function. If we draw one period of cosine, so it's from 0 to pi. Okay, so let's do just a sketch from 0 to pi, decreasing, and all from pi to 2 pi increasing. So that is the feature of the cosine function, 2 pi, right? Over the 2 pi, it's one period, but you can extend it to both ways then, and we can see more of the cosine function. So if you extend, right, so it will continue this pattern, go both ways, so continuous, and we can draw at least there's one horizontal line that will intersect with the curve more than once. So that shows it cannot be a one-to-one function. So in order for the cosine function to be one-to-one, let's restrict the curve over a smaller domain. That is, let's think just for one period, it's still not one-to-one. And then we erase that branch, only look at the cosine function from 0 to pi. So that is a cosine function. Let's show clearly this is the cosine function from 0 to pi, that interval. And the cosine function is strictly decreasing, right? From positive 1 decrease to negative 1. So it's definitely a one-to-one function because it intersects with any horizontal line at most once. Okay, so that is the cosine function we're going to find inverse for. So this is the cosine function. Right now we look at this cosine function, its domain is only on this interval from 0 to pi. And its range, which is the set of all possible y values, the function y values for cosine, will be any value from -1 to 1. So that is our cosine after it's being restricted until this interval, right? On this interval from 0 to pi, then we can find its inverse. The inverse function, how do we denote its inverse? So let's use the different color. So let me write cosine inverse. You see, that's the name, really, our writing for the inverse, right? That's the name. Or you can write it as arc cosine. So it's just the same function. You can write either cosine inverse or arc cosine. So both are names for the same inverse of cosine. And then this inverse function, still we intend to use x for the input variable for any function, so we choose the x. And for this inverse function, its domain will be -1 to 1. You see, same as the range of the original function, right? So that's the range of cosine, but becomes domain of the inverse of the cosine. So if domain of the inverse is this, what is the range of the inverse? The range of the inverse function is from 0 to pi. Yeah, 0 to pi, which is the domain of the cosine. So this is to see the relationship. Just for a function that is invertible, right? It's a domain and range. And the domain becomes the range of the inverse. The range of the cosine becomes domain of the inverse cosine. Now let's do a sketch of the inverse cosine function. To do a sketch, we just need to find, first, let's make use of the cosine, since we know we're going to restrict the cosine function from 0 to pi, right? We're going to pick several points. So from 0 to pi, this interval, and we will pick the point, for example, somewhere in the middle, which is half of pi. And this also another point, right? Between 0 and half of pi, there's a pi over 4. And there's another point between pi, half of pi and pi, there's a 3 pi over 4. So we just take different x values on this interval from 0 to pi. And then we try to look at the 5 points of cosine. So at 0, the cosine value is 1. At pi over 4, the cosine value is that number, square root of 2 over 2. At half of pi, the cosine value is 0. And then you see the cosine values at different axes, right? When x is increasing, cosine value is decreasing to -1. So it's a decreasing pattern. And we get these 5 points on the cosine curve. Then quickly we can find 5 points of the inverse cosine. That means for the inverse, if your input is 1, you are going to get 0, right? So that's, you see the reversed relationship. We're going to, if my input is 1 for the inverse function, I'm going to get 0. So 1, 0 must be a point on the inverse. So if this pair is an ordered pair on the original function, then the reverse, which is this pair, must be an ordered pair on its inverse. So we simply reverse the values on for each ordered pair of the original function, then we can find points for the inverse function. So similarly, when input value is 0, the output, you see when input value is 0, the output for inverse must be pi over 2, right? So same idea. So whenever you have AB as a point of the cosine, then BA must be a point on the inverse cosine. So for each ordered pair we reverse, we get a point on the, you see, if pi -1 is a point, then -1 pi must be a point on the inverse. So we get 5 points for the inverse cosine curve. So let's take a look at them. But you may want to say, okay, your x value you see after reverse, I want to put x value from small to big, right? Then I can see the y value, which is the cosine inverse cosine value is changing. What happens? So we want to just organize, just put this one first because this x, the input value from -1 gradually to +1. You see so we just put still the same 5 points. The only difference is that this ordered pair is placed at the beginning of the table. And then gradually with x increasing, right? Yeah, so each ordered pair is still there. And you see, this is the last ordered pair. So we just reversed the list of ordered pairs. So that means the same 5 points. But this way we can see property because for the inverse function, the x with x is getting larger and larger. What happens? The y value becomes smaller, right? From pi decreased to 0. So that means the cosine inverse is decreasing, which is true for a function that is invertible. When the original function is decreasing, the inverse is also decreasing. When the original function is increasing, the inverse is also increasing. So let's look at the 5 points. And before we plot inverse, you see the black points. These are the points of cosine. Yeah, cosine. So this branch, that's the cosine function over 0 to pi. On this interval, it's decreasing and it is 1 to 1. So we reverse from these 5 points, right? Each point supposed for any point of, if you know AB, then immediately you can find the corresponding point, which is here, BA, right? Whatever point you have for the cosine, then you can find a point for the cosine inverse. So here you see the cosine inverse will look like this. So we have 5 points, we plot them all, and each one is the right dot, right in right. So we connect all these 5 points, we see a sketch of the cosine inverse. And this, be careful, this cosine inverse, this x value has to be from -1 to 1. Yes, that's the domain of cosine inverse. And the range of cosine inverse is from 0 to pi. So you see the possible function value, right, for this is from 0 to pi, which is the domain of the cosine of that cosine function we did inverse for. Yeah. So, okay, so now we see this picture for inverse cosine. And this inverse cosine is decreasing function. Just like this cosine function, you see the cosine function where we did inverse, right? It's decreasing. So its inverse function is also decreasing. And remember the sine function, when we restrict the sine function over -half of pi to +half of pi, that part of the sine function was increasing. Its inverse was increasing as well. So the inverse has the same property as the original function in terms of increasing or decreasing. So let's evaluate the cosine, the inverse cosine at some values at negative half. So if you want to evaluate cosine inverse at negative half, so you're trying to decide the y value, the function value at when the function has an input, negative half. So to do this problem, we can rewrite it as you're looking for the y whose cosine value is negative half. Okay, that problem is a more friendly expression, right, compared to this inverse because it's too new. It is a new thing. So you have seen this cosine inverse right now, but then we try to convert it into a different way to realize what is y exactly. The y is such a y whose cosine value is negative half. So can we possibly find y? And remember, you are looking for the y over 0 to 2 pi. So this y has to be on that interval from 0 to pi whose cosine is negative half. So what is the y? If it's positive half, you know it's pi over 3. But if it's negative half on this interval, it will be pi minus pi over 3. So it's 2 pi over 3. Yeah, so that is the answer. So just try, if you want, you can even do a quick sketch for this. So you're using the cosine instead of the cosine inverse. If you try to think of cosine over this interval from 0 to pi, right? And you want to locate when this cosine value is negative half. Yeah. So that is the certain y you're looking for. Yeah. But if you think positive half is easier to do, so if you put positive half, then what is that? So that's the which y whose cosine is positive half. So that this is the y value, which is pi over 3. But this portion pi over 3, this is pi minus pi over 3. So it's a 2 pi over 3 will corresponding to the negative half. Yeah, so this is the y value when the input for the cosine inverse is negative half. So the y is 2 pi over 3. Next question. If the inverse has input value 3, what is the, yeah, we don't need to put parentheses because it's just the, okay, let's simply write as this. What is the function value? So the function value, y, if you rewrite, this is such a y whose cosine value is 3. No, it's undefined, right? The cosine value is never 3. We know this cosine inverse is only defined on this domain from -1 to 1. So when you give the 3, this number 3 is not in the domain of the cosine inverse. So this y is undefined. So this, the inverse function at 3 is undefined. Now, next question. Can we evaluate this inverse function, inverse cosine at square root of 3/2? So we try to determine the value, right? The value y of this arc cosine function at square root of 3/2. So this y must be must satisfy that cosine y is this number. Recall that y has to be from that interval, that is over this interval, 0 to pi. Yeah, so think of a y whose cosine is this value, but has to be from that interval. So this y must be pi over 6. Pi over 6. When it's pi over 6, cosine pi over 6 is square root of 3/2. So you have now evaluated several inverse, yes, just inverse cosine function at several locations. Sometimes it is undefined if your input is outside the domain of the inverse cosine. The domain, that means any value for the inverse cosine should be from -1 to +1 in order to find the inverse cosine.